Welcome to the O&M and DIY Manual on the Solar Desalination Greenhouse, an innovative solution for sustainable agriculture in arid regions. This guide will take you through the key features, installation, and operation of the SDGH, for desalination and plant cultivation, making it an ideal model for water-scarce environments. The SDGH at UCC employs a humidification-dehumidification process, leveraging the unique properties of halophytes to thrive in saline conditions, while simultaneously achieving passive cooling. This innovative system not only produces fresh water and crops through saline irrigation but also generates valuable biomass for biorefining, creating a new market for salt-tolerant plants. The integration and active condenser opens the possibilities of this sustainable agriculture model. The SDGH at UCC integrates a variety of components including a robust structure, vertical farming techniques, halophyte cultivation, efficient water storage and pumping systems, wet walls for humidity control, dehumidifiers, monitoring and control systems, renewable power supply, and a dedicated water source to support its operations. The structure of the SDGH at UCC is designed to be both functional and resilient, employing materials that withstand the specific environmental stresses while supporting the intricate systems within. Important considerations for operation and construction include ensuring structural integrity against varied climate conditions and facilitating easy access for maintenance and monitoring of the farming operations. It is engineered to optimize space usage while maintaining a controlled environment for the cultivation of halophytes and salt-tolerant plants. Vertical farming is a key component of the Solar Desalination Greenhouse, SDGH, that maximizes the utilization of space and promotes efficient plant growth. It involves cultivating crops in vertically stacked layers or racks, allowing for higher production yields in a controlled environment. Proper operation and maintenance of the vertical farming system are essential for achieving optimal plant growth and productivity. Operational procedures. Planting. Follow the recommended planting guidelines for each crop type. Ensure proper spacing between plants for adequate air circulation and light penetration. Nutrient management. Monitor and maintain the nutrient levels in the vertical farming system. Follow the recommended nutrient formulations and schedules for each crop. Regularly test the solution for pH and nutrient concentrations and adjust as needed to ensure optimal plant nutrition. Maintenance procedures. Crop monitoring. Regularly inspect the crops for signs of pests, diseases, or nutrient deficiencies. Take appropriate measures, such as implementing pest control strategies or adjusting nutrient levels, to maintain plant health and prevent the spread of diseases. Pruning and training. Prune and train the plants to promote proper growth and maximize space utilization. Remove dead or damaged plant parts and ensure adequate airflow within the vertical farming system. Train the plants to grow vertically or along support structures to optimize light exposure. System cleaning. Regularly clean the vertical farming system to remove debris, dust, or any potential contaminants. This includes cleaning grow trays, racks, irrigation components, and any equipment used in the system. Use mild cleaning solutions and ensure proper sanitation practices to prevent the growth of pathogens. Monitoring and control. Environmental monitoring. Install sensors or use manual methods to monitor key environmental parameters such as temperature and humidity levels. Regularly check and record these measurements to ensure the environmental conditions are within the desired range for optimal plant growth. Growth tracking. Monitor the growth progress of the crops by measuring plant height, leaf development, and overall plant health. Keep records of growth rates, yields, and any observed changes or abnormalities. Use this information to make informed decisions regarding crop management practices. Emergency procedures. Power outages. In the event of a power outage, implement emergency lighting or backup power sources to provide temporary lighting and maintain critical environmental conditions. Take measures to prevent temperature extremes or other adverse effects on the plants. System malfunctions. if any component of the vertical farming system malfunctions, promptly assess the issue and take appropriate action. This may involve repairing or replacing faulty equipment, adjusting nutrient levels, or implementing alternative growing methods temporarily. Proper operation and maintenance of the vertical farming system in the SDGH are vital for ensuring healthy crop growth and maximizing production. Regular monitoring, timely interventions, and adherence to best practices will contribute to the success of the vertical farming operation within the greenhouse. Halophytes, such as Salicornia species, thrive in saline conditions that most plants cannot tolerate, making them ideal for integration with aquaponic systems utilizing brackish water. Their cultivation involves planting in substrates that are regularly irrigated with nutrient-rich saline water. Maintenance of these salt-loving plants is straightforward, requiring periodic checks for salinity levels and ensuring that the hydroponic setup provides consistent moisture and aeration to support their growth. Different species of halophytes can be grown if sturdy enough or have a high market value. Here is a selection of plants from Ghana. The water storage and pumping system is an integral part of the SDGH at UCC, designed to efficiently manage the supply and circulation of saline and fresh water. It includes robust storage tanks that hold saline water for irrigation and harvested fresh water, coupled with pumps that ensure consistent water flow to various parts of the greenhouse. Regular maintenance of this system, including checking for leaks and ensuring pumps are functioning optimally, is crucial for the smooth operation of the greenhouse and the health of the plants. The wet walls in the SDGH at UCC play a crucial role in maintaining optimal humidity and temperature levels within the greenhouse. These walls are designed to absorb and evaporate water, creating a cooling effect that is essential for the growth of halophytes and other salt-tolerant plants. Regular monitoring and maintenance of the wet walls, including ensuring even water distribution and cleaning to prevent clogging, are vital for their efficiency and the overall climate control within the greenhouse. Make sure that the wet walls always have access to water. Connect a dependable water supply, such as a storage tank or a water line, to the water distribution system. Make sure the water distribution system is working properly by checking it often. Make any necessary repairs and check the distribution pipes for any clogs or leaks. Determine a schedule for wetting based on the desired humidity levels and conditions in the environment. During the active growing phase, the wet walls should be kept moist. Screen the dampness levels inside the nursery and change the wetting plan in like manner. Routinely review the wet walls for any indications of harm, like breaks or weakening. Prevent further damage and ensure optimal performance by promptly addressing any issues. The dehumidifier in the UCC's SDGH serves primarily to extract water from the air, providing a secondary source of water for the system. While it's not a critical component for environmental control, regular maintenance ensures its efficiency in water extraction and supports the overall water conservation goals of the SDGH. This feature can contribute to the sustainability of the greenhouse by recycling atmospheric moisture. A weather station helps to determine the conditions and precautions to take in advance. The power supply should to meet the energy demands of pumps, and eventual control mechanisms. The water source for the UCC's SDGH primarily consists of saline water, which is fundamental for both the irrigation of halophytes and the operation of the humidification-dehumidification system.